Right, hi and welcome to my third video from the graph theory series, and this one is about planar graphs and Euler's formula. So there's a learning goal, and here we go. A planar graph is a graph where the edges do not cross. Take, for example, graph 1 and 2 here. Now, it turns out that these are actually equivalent graphs. If you go through and just do the calculations, you'll see that B connects to A, D, and C, and it does here as well. A connects to all of them, and it does here. D connects to A and B. C connects to A and B, and it does in graph 1 as well. So they're equivalent or isomorphic graphs. But this one has two graphs that cross over each other when they shouldn't. The only time this kind of diagram should occur is if there's another vertex there, but there's not. So this is not a planar graph, and we'll be using planar graphs for some things later on. So we need to be able to draw them. And the easy way here, what we've done is we've taken line, the edge BD, and we've just moved it over the top of A. So it goes like this, and you can see that we've got the same diagram as over there. And that just means that we don't have that crossover. Only graph 2 is planar, and there's some more examples in your textbook. There are many ways to draw a single graph, but there will always be only one unique graph way that is planar. That's really important. Now, you've got to keep in mind, this is the planar version of this graph. I could pick it up and rotate it. I could change the length of edges. I could move C into here, but it's still the same graph essentially, if it's planar. So, recall that A, B, C, D are vertices. B to C, that little black line there, that's an edge. This graph is planar, as we've just explained, and this graph has three faces. So you can see in pink, it's got one face there, and this face, which is everything else. So the graph has 4 vertices, 5 edges, and 3 faces, and it's planar. That brings us to Euler's rule. Euler's formula, which was theorized by Leonhard Euler, and he proved it as well, that for any planar graph, vertices plus faces minus edges is equal to 2. So, and I've done my little variable definitions over on the side here. The number of vertices plus the number of faces minus the number of edges should always be equal to 2 in any graph that is planar, i.e. there's no crossover of edges. Does this work in the example above? 4 and 3 make 7, so 4 plus 3, vertices plus faces, minus edges, does indeed equal 2. And it will happen every time. Let's verify Euler's formula works in this case. So we've got V, our vertices. I've got 1, 2, 3, 4, 5, 6, 7, 8. Faces, F, I've got 1, 2, 3, 4, 5. And edges, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then V plus F minus E is equal to 8 plus 5 minus 11, which is indeed equal to 2. So Euler's formula works in the graph below. The next part of this example is, what if C did not exist, but the edges still did? So what if we removed C? So let's say I take it out. Now the tricky thing here is that we go, well, now there's only 7 vertices. And my number of faces obviously hasn't changed, and my edges is still 11. 7 plus 5 minus 11 equals 1. But this is still a planar graph. What you need to recognize is that earlier I counted this edge and this edge, which was this edge and this edge. If we remove that vertex, this all becomes one edge. So we actually lose an edge as well. You remove the vertex in this case, we lose an edge as well, and we get 7 plus 5 minus 10, and that's actually equal to 2, which works. So be aware of little things like that, and what I'm telling you is that Euler's formula will always work. Example, a planar graph has 6 vertices and 3 faces. How many edges does it have? Now remember, vertices plus faces minus edges equals 2. So 6 vertices, 3 faces minus e equals 2. So 9 minus e equals 2. Solve it however you like, but what equals 2 when I take it away from 9? E must equal 7. 9 minus 7. And so there's our number of edges. And that's, it's a fairly big concept, but there's not a lot that we can do with it. There's a little extension here. You can draw that graph if you want to. Remember, it's got 6 vertices. 1, 2, 3, 4, 5, 6. It has to be planar, and it should have, well, it should always work. So if I draw my edges in here and make sure they're all planar, 1, 2, 3, 4, 3, 4, 5, 6, 7. Is that 7? Yep. Done. I've got all my edges. There's my 7 things, and I've got 1, 2, 3 faces. It all works. Always works. So, can you define a planar graph and determine the number of edges, vertices, and faces it has? Can you explain and deduce isomorphic equivalent graphs if needed? Can you apply Euler's formula? And there is the learning goals and resources. All the best.